So this question says that we have a transverse wave that's traveling from left to right. So it gives us that it's traveling with a velocity in some medium. The direction of the instantaneous velocity of the medium at point P is what? They give us a couple words in here. They give us that it's a transverse wave. So this graph that they give us, I don't know where it starts, but I know it's an X and a Y graph. It's traveling at some velocity, and this thing is an S wave. It's the curvy wave. So if you have a hard time remembering S waves and P waves, S is the one that actually makes an S with the material. It's a shear wave or a secondary wave. So the shear waves are the ones that go both in, if it exists in the X direction, but they slide to the Y direction. Whereas the compression waves, the P waves are pressure waves, so they're the ones that compress in and out this way. So they don't have any motion in this direction. And actually, this transverse wave is going to tell us how this thing's moving. And really what's happening is that this point right here, because it's a transverse wave, is only allowed to go up and down. This point right here is only allowed to go up and down. These points right here are only allowed to go up and down. So we have to ask ourselves, are we going up or down in this case? So I can eliminate forward or up and forward because there is no forward direction. The velocity is forward, but that's where it looks like this peak is traveling. It's not where the actual points are traveling. So if they're going up, I want to know what happens a little bit later. So I'm going to say that this is T1. At T2, the wave is going to move a little bit. So instead of this peak being here, these points are going to move a little bit. So this guy is going to move a little bit forward in the velocity. This 0 point is going to move a little bit forward. This 0 point is going to move a little bit forward. This point right here moves a little bit forward. So we'll see that our slope, or not our slope, but our curve, get one more point here. Our whole entire thing shifted a little bit in the velocity direction. So this whole graph used to be this point here, now shifted over. This point here shifted over. The valley shifted over. So this point, P right here, it didn't shift left or right, it just moved up and down. So we can see that this point P now is at a higher direction. So A is the correct answer because in order for P to go more towards a crest, as this velocity moves through, as this graph slides through, P has to rise up. So if we think of this as a water wave moving forward, and this is a little buoy sitting somewhere in the wave, and we're not talking the waves near shore, we're talking a little bit offshore, that this buoy is going to go up as this wave travels by it. So if you ever get a chance to go play in the ocean, or have ever sat, say, on a surfboard before you've come in, this is what happens, is this wave will go up, and as the wave travels for it, you bob up and then bob down. I encourage you to go play in a bathtub with some waves, put a little rubber ducky in there and watch it go up and down.